Hello all. So conversions of DFA, NFA to DFA, we are having three conversions. So first conversion is converting NFA to DFA. Second conversion is NFA with epsilon to DFA conversion. Third one is NFA with epsilon to NFA without epsilon. Here we will see the conversion of NFA with epsilon to DFA. Let's see one example. Diagram, first we have to check whether this is a finite automata or not. Okay, so finite automata means it should satisfy 5 tuples, right? So the 5 tuples are m equal to q comma sigma comma delta comma q naught comma f. So these are the 5 tuples, right? So here this q represents the finite number of states. Okay, so in this automata we are having the finite number of states, which means q0, q1, q2. So these are the finite number of states. So here we can write q as q0, q1 and q2. Next one is sigma. Sigma means the number of input symbols. So here we are having the input symbol as 0, 1 and 2. Okay, and next one is delta. Delta means the transition. Of course, in this automata it has a transitions, right? So it has transition. Next one is q naught. Q naught means initial state. So here also we are having the q naught as the initial state, and f is a final state. So here we are having q2 as a final state. So this transition, which means this automata satisfies these 5 tuples, so that we can say this automata is a finite automata. Okay. Now we should check whether this automata is a finite DFA or NFA, which means deterministic finite automata or non-deterministic finite automata. Okay. So here we are having the input symbols 0, 1. Okay. So we are having 3 states, and in DFA, each state should have the transition by using 3 input symbols. But here we are having in this transition we should check in Q0 we are having only 2 transition. One is Z by using the input symbol 0 and by using the input symbol epsilon. Okay, epsilon is nothing but there may be a transition or may not be a transition. Okay, there may be a transition, by we couldn't say which input symbol we can use. Okay, that is what here they are mentioning the input symbol as epsilon. Okay, so in this conversion, we should change this NFA to with epsilon to DFA transition diagram. Okay, so let's see the conversion. So step 1. So in step 1, we should find the transition table. Transition table of NFA. So the states are Q0, Q1 and Q2. So here also Q0 is the initial state and Q2 is a final state. Okay. So here the state Q0 reading the input symbol 0, it will move on to the state Q0. Okay. The next Q0, there is no transition Q1 and there is no transition by using the input symbol 2, right? Next one is Q1. Q1 is reading the input symbol 1 and it will move on to the state Q1. There is no transition in 0 and there is no transition in 2. Okay. Next Q2. Q2 is reading the input symbol only 2. Okay. So that this is 2. So that there is no transition in Q1 and there is no transition in 0. Okay. So this is the transition table of NFA. Okay. The next step is find the epsilon closure. Find the epsilon closure. Okay. So first find the epsilon closure of Q0. Since Q0 is the initial state, we have to find the epsilon closure of Q0. Okay. So to find the epsilon closure of Q0, first we should write the states which we are considering here. So here we are considering this Q0. So that I am writing Q0 as the first state. Okay. Then we will move on to, we should see the transition of epsilon transition. Okay. So here we are in the state of Q0 and there is a epsilon transition from Q0 to Q1, right? So that we should write Q1 here. Okay. Now we are in the state of Q1 and there is again a epsilon transition from Q1 to Q2, right? So here we should write Q2. Okay. So epsilon closure of Q0 is Q0, Q1 and Q2. Like this we have to find the epsilon closure for the rest of the states. Okay. So next epsilon closure of next state is Q1. Okay. So Q1 means as I am considering Q1 here, I am writing Q1 as a epsilon closure. Okay. Now I am in the state of Q1, so I have to check whether there is a epsilon transition from Q1 to other states, right? Yes, there is a epsilon transition, which means Q1 to Q2. So I am writing Q2 here. So epsilon closure of Q1 is Q1 and Q2. Okay. Next one is epsilon closure of Q2. So epsilon closure of Q2 means since I am considering the state as Q2, so I am writing the state Q2 here and there is no more states after this Q2 because Q2 is a final state. Okay. So that I can stop this epsilon closure here. Okay. So the epsilon closure of Q0 is Q0, Q1, Q2. Epsilon closure of Q1 is Q1, Q2. Epsilon closure of Q2 is Q2. Now I am considering this as a new state, which means I am naming this as A. Okay. So in this conversion, we have to find the transition function for the new states alone. Okay, we have to find the transition function for this new states. Okay, so let's start to find the transition function. So we could find the epsilon closure. Next step is find transition function. Okay, so find transition function of new states. Which means I am naming the new state as A, so that I have to find the transition function of A comma 0, which means I have to find the transition function to all the inputs. Okay, so A comma 0 means here to find the transition function I have to find the epsilon closure of A comma 0. Transition function of, to find the transition function of A comma 0, first I have to find the epsilon closure of A comma 0. Okay, so epsilon closure of, instead of A I can write the states. Okay, so the states are Q0, Q1, Q2 comma 0. Okay, so epsilon closure of Q0 transition function of Q0 comma 0 union transition function of, here epsilon closure of transition function of A comma 0. So transition function V closure of transition function of Q0, Q1, Q2 comma 0. Next one is epsilon closure of transition function of Q0 comma 0 union transition function of Q1 comma 0 union transition function of Q2 comma 0. Okay, so we will get epsilon closure of transition function of Q0 comma 0. So Q0 comma 0 we will get the state as Q0 and transition function of Q1 comma 0. So Q1 comma 0 there is no transition, which means pi, and union transition function of Q2 comma 0. Transition function of Q2 comma 0 there is no transition, which means pi. So we are getting epsilon closure of Q0. So epsilon closure of Q0 means Q0, Q1, Q2, right? So transition function of A comma 0 equal to epsilon closure of Q0. So epsilon closure of Q0 means Q0, Q1, Q2, right? Q0, Q1 and Q2. Okay. Then next we have to find the transition function of A comma 1. We have complete the transition function of A comma 0. Now we will find the transition function of A comma 1. Okay. So to find the transition function of A comma 1, we have to find the epsilon closure of transition function of A comma 1. Okay. So epsilon closure of transition of A means Q0, Q1, Q2. So Q0 comma Q1 comma Q2 comma 1, right? So epsilon closure of transition of Q0 comma 1 union transition of Q1 comma 1 union transition of Q2 comma 1. So epsilon closure of transition of Q0 comma 1. So transition of Q0 comma 1 means there is no transition. So we can mark this as a pi. Union transition of Q1 comma 1. Q1 comma 1 means we are having the status Q1. Okay. So union Q1 union transition of Q2 comma 1. So Q2 comma 1 means there is no transition pi. Okay. So finally epsilon closure of Q1. Okay. So epsilon closure of Q1 means Q1, Q2, right? So transition of A comma 1 equal to Q1 comma Q2. Since this is a new state, I am marking this as a new state. I am naming this as a B. Naming this as B. Okay. The next, we have completed the finding the transition function A comma 0, A comma 1. Next, we have to find transition function of A comma 2. So epsilon closure of transition of A comma 2. So epsilon closure of transition of A means Q0, Q1, Q2, right? So Q0 comma Q1 comma Q2 comma 2. So epsilon closure of transition of Q0 comma 2 union transition of Q1 comma 2 union transition of Q2 comma 2. So epsilon closure of transition of Q0 comma 2. So transition of Q0 comma 2. There is no transition. So we can mark this as a pi union transition of Q1 comma 2. So Q1 comma 2 means again there is no transition. So that pi and union next one is transition of Q2 comma 2. So Q2 comma 2 means Q2 comma 2. So here we are having the state Q2. Right? So epsilon closure of Q2. So epsilon closure of Q2 means Q2. Okay. So again I am marking this as a new state and name this as a C. Okay. So we could find the transition function of A comma 0, A comma 1 and A comma 2. Likewise, we have to find the transition function of B comma 0, B comma 1, B comma 2 and then C comma 0, C comma 1, C comma 2. Okay. So next we can find the transition function of B comma 0. So transition function of B comma 0 means epsilon closure of transition of B comma 0, which means epsilon closure of transition of B means here we are having the status Q1 and Q2. So Q1 comma Q2 comma 0. So epsilon closure of transition of Q1 comma 0 union transition of Q2 comma 0. So epsilon closure of transition of Q1 comma 0. So here we are having the transition Q1 comma 0, which means there is no transition. So we can mark this as a pi union transition of Q2 comma 0. So Q2 comma 0 means Q2 comma 0. Again we are having no transition. So that we can mark this as also pi. Okay. So epsilon closure of pi, which means pi. So that transition of B comma 0 means pi. Okay. Next we have to find transition of B comma 1. Okay. So epsilon closure of transition of epsilon closure of B means Q1, Q2. So that transition function of Q1 comma Q2 comma 1. So epsilon closure of transition of Q1 comma 1 union transition of Q2 comma 1. Okay. So epsilon closure of Q1 comma 1 means Q1 comma 1. So we are having the status Q1. Q1 union transition of Q2 comma 1, right? So Q2 comma 1 means Q2 comma 1. Here we have no transition, so that pi. So epsilon closure of Q1. So epsilon closure of Q1 means Q1, Q2, right? So Q1 comma Q2. So this Q1, Q2 is already we had marked this as a B state, okay, so that I can leave this as it is, okay. So we have completed B comma 1. Next transition function of B comma 2, okay. So epsilon closure of transition of B comma 2. So epsilon closure of transition of B means Q1, Q2. Q1 comma Q2 comma 2 equal to epsilon closure of transition of Q1 comma 2 union transition of Q2 comma 2. So epsilon closure of Q1 comma 2. So Q1 comma 2 means there is no transition, right? So we can mark this as a pi union transition of Q2 comma 2, right? So Q2 comma 2. So Q2 comma 2 we are having the status Q2, right? So Q2. Okay. So epsilon closure of Q2. So epsilon closure of Q2. So epsilon closure of Q2 means Q2. Okay. So again we will check this states with the previous states. Already I am having this Q2 as a new state C. So I can leave this as it is. Okay. So we have completed A comma 0, A comma 1, A comma 2, B comma 0, B comma 1, B comma 2. Now we have to find C comma 0, C comma 1 and C comma 2. Okay. So transition of C comma 0, which means epsilon closure of C comma transition of C comma 0, which means epsilon closure of transition of C means Q2, right? So Q2 comma 0. So Q2 comma 0 means epsilon closure of Q2 comma 0. So Q2 comma 0. Q2 comma 0 means there is no transition, which means pi. Okay, pi. Okay. Next is transition of C comma 1. So that epsilon closure of transition of C comma 1, which means epsilon closure of transition of Q2 comma 1. Okay. So Q2 comma 1 means Q2 comma 1. Again here is no transition. So that epsilon closure of pi, which means pi. Okay. Next one is transition of C comma 2. So epsilon closure of transition of C comma 2. So epsilon closure of transition of Q2 comma 2. So epsilon closure of transition of Q2 comma 2. So transition of Q2 comma 2 means here we are having the state Q2. So that we can mark this as a Q2. Okay. So epsilon closure of Q2 means the answer is Q2. So this is what we can find the transition function. Okay. The next step is to find the which means to construct the transition table. Here we are having the input as 0, 1, 2, and here we are having the inputs, I mean states as A, B, C, because we are having the new states A, B and C. So A, B and C. Okay. Now we will fill this transition table. So the state A reading the input symbol 0 and it will move A comma 0, which means transition of A comma 0, it will move on to Q1, Q2, Q0, Q1, Q2, which means A, right? So A. Next is A1. So transition of A1 means Q0, sorry, Q1, Q2, which means transition state, which means the state of B. So here B. Next is A2. Okay. So A2 means transition of A comma 2. So it will reach the state Q2, which means C. Next one is B comma 0. So B comma 0 means pi, which means there is no transition. And B comma 1. So B comma 1 means Q1, Q2. So Q1, Q2 means the state of B. So B and B comma 2. So B comma 2 means Q2. Q2 means the state of C. Okay. The next one is C comma 0. So C comma 0 means there is no transition. So that pi. C comma 1. So C comma 1 means again there is no transition and pi. C comma 2. C comma 2 means the state of Q2. The state of Q2 means we could name this as a C. So that C. So this is the transition table of DFA. Now we should construct the transition diagram. So here the initial state is A and in B, C. So in A state we are having Q0 and B state we are having Q0, Q2 and C state we are having Q2, right? So in our questions we are having Q2 as a final state, so that in this DFA all the states we should mark this as a final state. Okay. So now we should construct the transition diagram. So A, B and C. So A is the initial state and this is also the final state, and B is also a final state, C is also a final state. Okay. Now A state reading the input symbol A and it will move on to the state A. So 0. A state reading the input symbol 1 and moving the state B. Okay, 1. A state reading the input symbol 2 and moving the state C. So 2. B state reading the input symbol 0 and there is no transition. Next B state reading the input symbol 1 and moving to B. And B state reading the input symbol 2 and moving to the state C. Okay. C state there is no transition and reading the input symbol 2, and it will move on to the state 2. So this is the DFA diagram, but in this is not enough, right? Because in DFA, all the states should read all the inputs, right? So, but in our question, in this problem, we are having 3 pi transition, which means there is no transition, so that we could create a dead state and mark these empty transitions, okay, which means from B by using the input symbol 0. So from B by reading the input symbol 0, from C by reading the input symbols 0 and 1. From C, input symbol 0 and 1. So which means there is a transition, but this state could not reach the final state. Okay, this is what the meaning. Okay, so this is the final DFA, so that we can convert this NFA with epsilon to DFA. Thank you.